Alright, at this point, you guys should have all finished up this little review that I made up. If there was some that you couldn't finish, that's okay, because that was kind of the point of this. It's kind of the formative before the formative. So this should give you a good indication of what you're struggling with so that you can go home and review it tonight before the formative tomorrow. So, number one. Now this is going to be I'm going to try to put the learning target every time so that you can know, okay, I need to go home and review learning target 9. Okay, so make sure you're writing down what I'm writing down, unless you have it, because this can be a study guide. Again, if you don't know it right now, you're not going to know it tomorrow just because you're listening to what I'm saying. You're going to go home, you have to go home and practice. So, Slammin' Sammy wants to create snack bags for a trip she is going on. She has 18 granola bars and 12 pieces of dried fruit. If the snack bags should be identical, without any food left over, what is the largest number of snack bags Serena can make? That's supposed to be Sammy, but that's fine. All right, so there we go. So we've got to figure out whether or not this is a GCF or if this is an LCM type of question. That's where we've got to start. So we have to determine whether it's a GCF or an LCM type of question. Okay, now in your notes, I gave you two boxes that had some buzzwords that can help you to identify whether it is a GCF or an LCM question. So this question, I underlined some of as I was reading there. Okay, and anytime you see a word that means largest, biggest, greatest, you know, we talked about that. We are always going to be talking about a GCF type of question. But more importantly, she's taking these pieces of fruit and these granola bars and she's grouping them up, putting them into groups that are with smaller amounts of granola bars in each snack bag. So that's another buzzword that kind of tips you off that we're talking about greatest common factor. So let's go ahead and find the GCF. So again, you should always start with your prime factorization, which I'll do that real quick just because I know that the majority of you are pros with it by now. There we go. Now remember, we got to take those and stack them up. So 2 times 2 times 3, that's going to be 12, and then for 18 would be 2 times 3 times 3. Now remember, when we're doing GCF, we look for CFs at this step right here, and I see a common 2, and I see a common 3. So I'm going to do 2 times 3, and I'm going to get 6. That means the largest amount of snack bags she can make would be 6 snack bags. Okay, so if you didn't have any of this, remember, you need to be writing it. You need to be, because this is your study guide now. Okay? Now, let's say you accidentally found the LCM. Okay, now I can tell you that the LCM for 18 and 12 is 36. Okay, I just know that off the top of my head. So I know that's 36. If you would have found 36, and like if you just made a mistake here, you got largest confused with least, whatever. You make a mistake and you do get the LCM to be 36. Ask yourself for a second, is it possible that Sammy is going to be able to make 36 different snack bags? Think about it. 1, 2, 3, 4, 5, 6. Times 6 of those, okay? You don't have to write this. Times 6 of those, so 36 total bags, but yet she only has 18 granola bars and 12 pieces of dried fruit. That means she has 28, just 12 plus 8, 30 pieces of food in general. How is she going to have 30 pieces of food and separate them into 36 groups? Okay, so that can just be a way to check yourself. So the answer was 6, okay? Now, I always like to draw these out like this, like I'm about to do here. And you can do it up top of your paper or wherever, but I'm going to draw these 6 bags. Each one of these is representing one snack bag. Okay, snack bag, okay? And then if I know that she has 18 granola bars, and I want to know how many granola bars are going to be in each one, I'm just going to take the whole, which is the total amount of granola bars she has, and I'm going to divide it by the amount of groups that there are. And in this case, there are 6 snack bags, so I know that she's going to have 3 in each. Now that makes sense because if you think about it, if she has 3 granola bars in each one of these, and I wrote it for all of them, 3 plus 3 plus 3 plus 3 plus 3 plus 3 is 18, which is how many you should have. Okay? For the pieces of dried fruit, she has 12 pieces of dried fruit. So therefore, she can take the 12, divide it by the 6 groups. You know there's going to be 2 pieces of dried fruit in each one. Okay? So that's kind of taking the GCF and the LCM and going a step further with it. But you just take the whatever the total number of granola bars or pieces of dried fruit, and you're going to divide it by the amount of groups, and that's going to give you the amount in each group. Okay? All right, number 2. Mr. Zenker goes to work out every 10 days and plays basketball every 15 days. He did both kinds of these activities today. Oh boy. He did both kinds. How about just, that's bad on my part. Sorry about that. Both kinds of activities today, which means he did both of them right now. How many days from now will he do both hiking and swimming? So that's supposed to be due. Geez, there's a lot of issues here. Okay, now, this is a problem. This is supposed to be basketball, and this is supposed to be working out. Okay, regardless, we want to know when both of them are going to happen at the same time. Sorry about that. So, I know that I need to figure out whether it's an LCM or a GCF once again. Okay, now, there's a word. I mean, you should see again. Okay, there's other words that you see, but remember there's one word that's always going to be LCM, and that's going to be when you are trying to figure out when 2 things are going to happen in the future. Please write that just to remind yourself. Okay, so the first step here is to do your prime factorization, 15 and 10. So this would be 2 and 5. This would be 3 and 5. Okay, so 2 times 5 and 3 times 5. We look for remember this is an LCM, but the first step to LCM is to do the GCF. So let's find the GCF. So hopefully all of you were thinking, obviously, the GCF is 5. Remember, that's not the answer, okay? You got to now take that GCF and you got to multiply it by anything not used over here in your prime factorization. So times 2 times 3, which is going to give you 30 days. So that means that in 30 days, Mr. Zenker is going to do both of those, basketball and working out, in the same exact day. Okay? That would mean then he'll at 30 days, 60 days, 90 days, 120 days. So if he was planning his calendar, every 30 days is going to be one where he's going to have both basketball and working out. All right, Mr. Glassburn is making flower arrangements. He has 15 roses and 30 daisies. If Mr. Glassburn wants to make all the arrangements identical and have no flowers left over, what is the maximum amount of flower arrangements that he can make? Again, I can underline flower arrangements because that is a group. You're putting these into groups. You're taking these total roses and daisies and putting them into groups. Okay? So, I look here and I say, is this a GCF or an LCM? Hopefully you all know that it's a GCF. So let's go ahead and find the prime factorization for 15 and 30. So there we go. 5 and 6. So that's going to be 3 times 5 and 2 times 3 times 5. We look for CFs. I see a common factor of 3. And I see a common factor of 5. How many of those are we going to use? 1 of each. And I find that my GCF is 5. I know that Mr. Glassburn can make a maximum of 15 flower arrangements. Okay? So now we're going to take this information right here and we're going to expand on it. We're going to go a little bit further. So what this means is with these 15 roses and 30 daisies, Mr. Glassburn can make these 15 arrangements. So there's 5, there's 10, and there's 15. That's how many he can make. With the information he's given us, that's what he can make. Okay, so if we want to know how many roses are going to be in each one of those, well, you go up and say, well, he's got 15 total roses. That's the total. And we need to divide that into the 15 groups. That means he's going to have 1 rose per arrangement. For daisies, he has 30 daisies, so that means that you're going to take the total number of daisies and divide it by the number of groups or arrangements, and that's 15. So that means 2 daisies. So what that means is that if you wanted to know now how many total flowers are going to be in each arrangement, you can just add them. There's going to be 1 rose and 2 daisies in each one. So there's going to be 3 flowers in each one. And if you added all those up, all 3 plus 3 plus 3 plus 3 plus 3, it had better give you 45, because I know that 30 plus 45 is going to give you, 30 plus 15 is going to give you 45. Okay? Remember, this is all learning target 9. This whole first 3, and then here in a minute the 4th one. Okay, they're all learning target 9, doing word problems with GCF and LCM. Okay, here's one more. So we have Mrs. Godfrey takes 12 minutes to finish a puzzle. By the way, this question right here is on the test, just so you know. It takes Mrs. Savely 10 minutes to complete a puzzle. If they both start right now, in how many minutes will they both finish a puzzle at the exact same time? Okay, so hopefully we all know that it's an LCM question because future, and you're trying to figure out when these things are going to happen at the same time. That's an LCM type question. So the first step is to do your prime factorization. There we go, got that. And then 10 is just 2 and 5. We're going to stack these up now. Now remember, the first step to GCF, the first step to LCM is to find the GCF. So I come up here and I say, okay, that means my GCF equals 2. Okay, so I know that that's my GCF. Now, the second step to LCM is to take your GCF and multiply by anything not circled up here, anything that wasn't in common. And we do that, and we are going to get 60. So, what does that mean? That means in 60 minutes, at the 60-minute mark, so they start right here at 60 minutes, Mrs. Godfrey and Mrs. Savely are both going to say done at the exact same time because they're both going to finish a puzzle at the same time. All right? So we want to know how many puzzles Mrs. Godfrey is going to finish during that time. Well, let's look at it here. If we know Godfrey's finishing one every 12 minutes, if she starts right now, she'll finish one in 12 minutes, 24 minutes, 36 minutes, 48 minutes, and at 60 minutes. Okay? Whereas Savely, she is finishing one every 10 minutes. So 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, and 60 minutes. Okay? So right there you can see they're both finishing at 60 minutes. That's why they're multiples of each other. So there's 2 ways to do it. You could list them out like this and say, okay, Godfrey finished 1, 2, 3, 4, 5. Mrs. Godfrey finished 5 puzzles in that time. Mrs. Savely, she's doing it a little quicker. She's finishing it 2 minutes shorter. So she's actually going to finish 1, 2, 3, 4, 5, 6. Okay? So that's that. The other way to do this is, I'll take A and put it down here now. So, is to take the time that it took them, or the total time that they're the multiple, the least common multiple, and then you're going to divide it by the amount of time it takes Godfrey to finish each puzzle, and that would give you 5 per, or 5 the whole 60 minutes. And then Savely, you'd use the same thing, 60, and then you're going to divide it by 10 because she finishes one every 10 minutes, and then you're going to get 6. Same answer either way. Okay? Alright, so all of those 4 there are all learning target 9. You got your practice sheets, you got your video, you got your notes. Use them. These questions are right off the test, essentially. Alright, distributive property. This is the one we did yesterday, which you guys were all good at. Remember, this is the one that looks like this. I'll write it real big here so we can all see it. Okay, we've got to remember that the GCF goes on the outside, and then the numbers on the inside are what you have to distribute to get you back to here. Okay? You guys all pretty much, from what I saw, everybody found this pretty easy. So the first step here is to do your prime factorization. Okay? 2 and 4, 2 and 2. This is 2 and 6, and then 2 and 3. So we'll stack those up. 2 times 2 times 2, and 2 times 2 times 3. And those are common. Those are common. So I know this has a GCF of 4. So again, that goes on the outside of the parentheses like this. Now just ask yourself, 4 times what would get me back to 8? 2. 4 times what would get me back to 12? 3. And then always just check it real quick just to make sure that it does equal the same thing. 4 times 2 is 8, plus 4 times 3 is 12. And that is the exact same thing. This would be the answer though. Okay? Next one, do your prime factorization. To save a little time here, I'll do 3 times 5. And then I will do 2 times 3 times 5. We look to see what they have in common. I see that they have a common 3 and they have a common 5. So I know my GCF is going to be 15. And then just ask yourself, 15 times what would give me 15? 1. 15 times what would give me 30? 2. Okay? Next one, prime factorizations for this, for 21 would be 3 times 7. 35 would be 5 times 7. What do they have in common? They have a common 7. So that means that is the GCF. And then it's pretty easy. 7 times what is 21? 3. It's right there. 7 times what is 35? 5. Those are your answers. This right here is learning target number 10. So if you know this is something that you are still struggling with, you need to make a note somewhere to say to really practice this before Thursday's test. All right. Okay, next one, find the GCF and the LCM. We've done a bunch of these, so I'm going to skip this step, but if you don't have it on the test, it will be wrong. Okay, so 48 would be 2 times 2 times 2 times 2 times 3. 36 would be 2 times 2 times 3 times 3. Okay, we look for CFs. I see a common 2. I see a common 2. And then I see a common 3. So I bring one of those down from each one. 2 times 2 times 3. And that's going to give me 12. We're going to ask ourselves just to make sure, is 12 a factor of 36? Yes, it is. Is 12 a factor of 48? Yes, it is. Next one, we got 21 and 27. So I'll skip the prime factorization step just to save some time. And there we go. What do they have in common? They have a 3 in common. And that's the only thing they have in common. So that is the only greatest common factor other than 1. Okay, if you're struggling with the GCF, that is going to be learning target number 7. Okay, learning target number 7, we go through that. LCM. Okay, now I use the same numbers. I did that on purpose. Okay, so when I look at this, I can say, okay, so I don't have to redo all this work. You could, but the whole point, remember, when you're finding LCM, first step 1, find the GCF. That's step 1. So we already know that, so we're going to take that GCF, and then step 2 is to multiply by anything not used up here. Okay? So I know that that is going to be 12 times 2 times 2 times 3. Okay? And that is going to be, it's going to be 12 times 2, whoops, times 2 times 2 times 3, be 144. There's your LCM. Okay? This one over here, I know my GCF is 3, so I'm just going to multiply it by 7 by 9. And let's do it. I don't know that one off the top of my head. 3 times 7 times 9 gives me 189. And there we go. Okay? So this is learning target number 8, by the way. Number 8, LCM questions are number 8. So if you need extra practice, go ahead and check those out. All right. Last couple here. All right, number lines. This is the one that we haven't done since the first Monday of the school year. Okay. First of all, we got to know what a horizontal and a vertical is. Horizontal is side to side. Okay. Vertical is up and down like this. Okay. I'll draw a different. I'll put that one. There we go. Okay. So here we have a horizontal number line. Okay. Vertical up and down, horizontal side to side. So we need to draw a horizontal number line that represents whole numbers between 4 and 9. Okay. Now the biggest mistake here is, remember I gave you this example. I said you don't have to write this or anything, just watch. If I put everybody in every one of my classes, and then let's say I had a Mike, which I don't, and I had a Mark at the end, and then I had all these kids in between them. Everybody, so I'll just show them with X's. I have all these kids. There we go. I got all these kids standing here. And I said, hey, everybody between Mark and Mike, come see me. Would Mark and Mike come see me? Hopefully you're all saying no. Because I said between them. We would not include them in who I'm talking about because I said I used that particular word, between. Okay? So, when we're doing this, we know we cannot include 4 or 9 on this number line. So what's the next whole number after 4? 5, 6, 7, and 8. And that's all you would put on your number line, is those numbers. Okay? You would not put 4, you would not put 9 because of that word between. Okay? All right, drawing a vertical number line to represent even whole numbers. Okay, now the biggest thing with your vertical number lines is just keeping in mind that it's got to be, you got to make sure you know the smaller numbers are towards the bottom. Okay, we've got to know that. That's the biggest thing that I've seen a problem with. Okay, I see some people like this is wrong, but like they're numbering number lines like this: 8, 9, 10, 11, 12, something like that. That is wrong. Remember, think of a thermometer. The warmer temperatures are at the top. Okay? So let's figure out what the wording is here. Draw a vertical number line to represent even whole numbers from 8 to 14. So this number line only wants whole numbers. Specifically, it only wants even whole numbers. So, since it says the word from, should I start at 8? Yes. Is it even? Yes. Is it a whole number? Yes. And since it says from 8, that's where I should start it. And remember, that's where the lower numbers go, at the bottom. Now, what's the next even whole number after that? 10. What's the next one after that? 12. What's the next one? Well, if this right here would say between instead of from, you'd be done. You would not include 14 or 8. But because it says from 8 to 14, we are absolutely going to include it on our vertical number line. Okay? All right. Here's this one. Hopefully you have some room off to the side here. We're going to do another vertical number line. All right. So let's read it first of all. Draw a vertical number line representing rational numbers from 3 to 4. Remember, rational numbers, any number can be rational pretty much, except for some, which really doesn't matter. But the number 2, that's a rational number. The number 3 is a rational number. It's pretty much any number that can become a fraction. Just go with that definition for now, and you'll learn what it really is later on. But for instance, remember the number pi, which is, you guys know that, 3.14, and it goes on forever and always. That is not a rational number. So a decimal that goes on forever is not rational like that. Okay? So that's that. So rational, any of these numbers, 4.29, that's a rational number. Okay? So it says you want the rational number representing numbers from 3 to 4. So because it says from 3, we're going to start at 3 and we're going to work our way up to 4. Now the interval size is how much each little tick goes up by. So if we're going up by 1/10, then this would be 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, and then obviously you add one more, and that's going to make it be 4 or 4.0. Okay, so you would need to have all those on there. Okay, all of those numbers. Okay, this one here, we're doing mixed numbers, which is the same as, this right here, 3.5, that could become a mixed number. Remember, 3 and 5 tenths. Okay, that's a mixed number. So they're the same thing. Only thing here is we're going to be doing a horizontal number line here. Okay, horizontal. Okay, so we're going to represent mixed numbers between, there's that word again, between, so that would mean we are not going to include 4 or 6 on the number line. We had one just like this on our review sheet number 2, if you guys remember. So what is the first 1/4 after 4? It is 4 1/4. And then we would go to 4 2/4, better known as 4 1/2, 4 3/4. And then we would get 4 4/4. Now, what is 4 4/4? Well, that's saying I have 4 whole pizzas and I have 4 out of 4 slices of another pizza. So actually that means I have 5 pizzas, 5 whole pizzas. Then I go to 5 1/4, and then here we go again, 5 2/4, simplified, 5 1/2, and then we have 5 3/4, and I stop. I am not going to have 4 or 6 on that number line because it says between. If it would say mixed numbers from 4 to 6, then we would include it. All right? So any of those number line things, look back to your learning targets number 1, 2, and 3, worksheets, notes, videos, whatever. Okay? You may want to just refresh yourself tonight on that. Okay, now we're going to list all the factors of 24. Okay, now this is a tough one, and some students, what they do is they'll go through and they'll do this. They'll list every number. This is a big pain, but I'll do it real quick. They list every single number all the way to 24. I don't think this is really necessary, but if this would help you to actually get it right, then that's great. These are all numbers from 1 to 24, so all numbers 24 or less. Okay, and then you can go through and just highlight or circle the ones you know. Now we should start there. We know those are factors. Those are factors of all numbers. Okay, now we got to go through. Well, it's even, so it has to have a factor of 2. 3. Use the divisibility rule for 3. 2 plus 4 is 6. Does 6 have a factor of 3? Yes, it does. There we go. 4. Your rule doesn't really help here with 4, but if you know that 4 times 6 is 24, then yeah, 4 would also be a factor. Absolutely. Okay. 5. Hopefully you're all saying no because it does not end in 5 or 0. 6. Yeah, I just said 4 times 6. Okay. 7. Nope. 7 times 3 is 21. 7 times 4 is 28. Okay. Then we have 8. Hopefully you know that 8 times 3 is 24. And then from there, 9, no. 10 doesn't end in 0. 11, no. 12, absolutely. 2 times 12. Okay. And then 13, 14, 15, 16, 17, 18, no. 20, all these, no. There we go. So it's really not necessary to list them all out like that, but if that helped you, do it, please. Okay. Now we're going to list the first 5 multiples of 8. Remember, the first one is 8, 16, 24, 32, and 40. That's what you got to have. You got to make sure you don't skip 8. A lot of people do it. Okay? All right. Make sure you guys are studying for it. I think you guys are going to do well. See ya.